Hey, ladies and gentlemen, today we are going to do Unit 4, Notes 2, Factor by Grouping. So let's first just talk about factor by grouping. We used factoring by grouping and the distributive property when we are factoring polynomials with 4 terms. Don't forget, pause the video if you need to be able to write some of this stuff down. So here's our steps for factor by grouping. You're going to group the two terms into two groups of 2. You're going to pull the GCF, the greatest common factor, out of each group. You're going to check to make sure that the leftovers match. You're going to factor out the leftovers like a GCF, and then you're going to write the 2 factors. So go ahead and pause here so you get that written down. All right, so let's go ahead and start and look at our first one here. And a lot of us probably automatically look at this and go, oh my goodness, I want to add those 2 middle terms because they're like terms. But actually, we want to keep them separated. That is what is going to allow us to do factor by grouping. So we have our first 2 terms. So first off, is the greatest common factor that I can take out of all 4 of these terms? There's not. It looks almost like I could take a 2 out. First one doesn't have a coefficient. Looks almost like I could take an x out. The last term doesn't have a variable. So I can't take anything out of all of them. Now, when we talked in 4.1, we talked about that as prime. But when it's something that has 3 or 4 terms, we actually can do factor by grouping. We're going to look at 3-term ones in 4.3 notes, factoring trinomials. So let's go ahead. We're going to start off by putting these in 2 groups of 2. So now we are looking at this as really like 2 small GCF. So if I look at my first set of parentheses, squared plus 2x, and I want to look for a greatest common factor out of that. Then I can take an x out of both of those, and I'm going to write x plus 2 in my parentheses. Please bear with me if my writing looks sloppy. I'm using my finger on my computer. All right, so now we're putting a pause on that, and we're going to look for a second set of terms. And 4x plus 8, and I can take a 4 out of both of those. And I'm actually going to take out positive 4. So I write plus 4 there. And my leftover terms, if I divide out a 4, I'm left with x plus 2. So now we look at this, and we want to make sure our leftovers match. And the leftovers are the things inside the parentheses. Well, do those parentheses match? And they do. So technically what we're doing is we're going to factor that x plus 2 out of those 2 portions. I'll put that into 1 parenthesis. And then my leftovers, x plus 4, into the other parentheses. And this is going to be my solution. So think back to Unit 3 where we did FOIL and box method. The problems began like this. And so like I said multiple times, Unit 4 is really undoing Unit 3. And you just successfully did your first factor by grouping problem. Okay, I'm going to go ahead and erase that. Give myself some more problem 2. All right, so if we look at problem 2, we again want to see, is there a greatest common factor we can take out of all of our terms? And in this case, we do have one. We can take a 3 out of all 4 of those terms. What we're going to do is make the rest of our problem smaller, and that makes it easier for us to graph or to factor. So I'm going to take 3 out. So I'm left with x squared minus 2x plus 3x minus 6. All right. So now that 3 on the outside is just going to tag along. It becomes this like awkward third wheel. It just tags along on the rest of the grouping problem, and it stays there the whole time. So next, I'm going to go ahead and I'm switching colors so you can see. We're going to factor by grouping the 4 terms inside. So I'm putting the first 2 in parentheses and the second 2 in parentheses. All right, 3 tags along. Now I'm going to switch to using a brace, just to denote that everything inside the braces goes together. So x squared minus 2x, I'm looking for my GCF there, and that is going to give me x. And when I factor out an x in both of those, it's x minus 2. Now I look at my second set of parentheses, and I have 3x minus 6. And so there, my greatest common factor is a positive 3. And I get leftover of x minus 2. And then I gotta put a bracket at the end. Okay, our next is to make sure do our leftovers in parentheses match. They do in this case, that's great. If they ever don't, usually it just means you didn't factor one of them fully. All right, so I'm going to put 3 in my brace. I'm going to write my first parentheses, x minus 2. And then I write my leftovers into my extra set of parentheses, x plus 3. And in fact, I can go through and delete this brace here. And yet I can move that 3 right next to the problem. So this is my solution. 3 times x minus 2 times x plus 3. Now, if we don't notice that there's a greatest common factor in it, we still can factor by grouping that original problem. But we always want to factor out any greatest common factor with any factoring problems we're doing and make it simpler for us. All right, so let's go ahead and go through our next 2 problems. I want you to pause the video here and take some time to try out problem 3 and problem 4. When you come back, we'll look at those. All right, so I want you to take a look. All I did was problem 3 so far, and you'll see that I have 2 answers inside that box. Now, you'll notice they have the same things inside the parentheses. We have x plus 2 and 2x plus 5. Or we have it the other order, 2x plus 5 and x plus 2. So here's the thing. It does not matter the order. Think about this. If I take 3 times 6, I get the same solution as if I take 6 times 3. Multiplication, the order doesn't matter. So same thing here. So when you're going through, if you have it in a different order of your parentheses than I do or your neighbor does, that's okay, as long as the information inside your parentheses is still the same. All right, so I'm going to pause here and I'm going to do problem 4 out for you, and then you'll check that one out. All right, did you catch that you had to pull out a greatest common factor of 5? If you didn't, I want you to go in and do that into your notes right now, because if you don't, we end up with 2 other different answers. And so consistency, again, pull the greatest common factor out, make the problem smaller right away from the beginning. All right, let's go ahead and move to our next ones. Now, if we look here, these 2 problems have higher exponents. We see a p cubed in there. That is something new for us. So let's go ahead and look and see if I can factor out any GCF in our first problem, in problem 5. Okay, so similar to some we saw yesterday, we can factor greatest common factor out of like 2 of them, but not all 4 of them. So let's go ahead and break this up into my first and this. So 12p minus 21p squared. So in this case, we are going to have a greatest common factor number of 3, and we're going to have a variable of p squared this time. So keep in mind, we have a variable and a number. Sometimes it can be a variable that's squared or cubed or something like that, but anything is possible for a greatest common factor. So when we pull that out, we're left with 4p minus 7. All right, so let's go ahead and look at our second 2. And if we look at our second 2 terms, we can pull a 7 out of both of those. And it's going to be a positive. And we get left with 4p minus 7. Again, this really good indicator is if your leftovers don't match, it means you did take out the correct greatest common factor. I also use this as a hint of, hey, I'm stumped on what it is. So I look like, oh, this 28, I need that to become a 4. So what do I have to divide by to make that a 4? All right. And then 3 and square. So 7. So we have 4p minus 7 times 3p squared plus 7. All right, I'm going to go ahead and clear this off for us. So let's go ahead and look at the next problem. In this one, do we have a greatest common factor we can pull out of everything? And we don't. So I want you to break it into the first two and the second two. So I want you to take a pause here. It's just, there we go. Take a pause here. And I want you guys to try this one on your own. And then let's come back together and discuss what happened. Okay, so hopefully you noticed that we could take an 8r squared out of our first two terms. And if you got stumped on the second two, our greatest common factor to pull out here was just 1. That is what gave us equivalent things in our, or matching things in our leftovers. We have r minus 8, and then we have 8r squared plus 1. Okay, and you do have to take that 1 out, otherwise we don't have that second term, and if we FOILed our box method, we would not end up with the same thing. All right, so let's go ahead and look here. Oh, I really like problem 7 because it shows us another unique thing. All right, so is there a greatest common factor to pull out of all of it? No, there's not. So when I divide that out, I'm going to be left with this. And here's one of the parts I really like. I have a 2x squared, and I'm dividing out a 2x squared. You need to leave up. So if you factor something out, you have that placeholder 1 there. Now let's look at our second two. I have negative 30x minus 5. This one is going to have a greatest common factor of negative 6. We haven't really done a lot of greatest common factors with negative numbers. In fact, Mrs. Matheson uses the idea that if the third term is negative, regardless of the fourth term is, you're going to pull a negative greatest common factor out. Okay? And not 6, with 5, you guys. It's a negative 5. Plus 1. Negative 5 divided by negative 5 turns into a positive 1. Okay, so leftover match, and then our other pieces square minus 5. Again, it doesn't matter which set of parentheses goes first. All right, so I would like you to pause and try out problem 8 on your own. When you come back, I'll have it done for you. All right, so not a greater common factor pull out of all of them. Just a little bit different numbers that we're not probably used to finding common multiples with. Common factors from 6 and 16, we could pull out a 2 and a v squared, and we're left with 3v minus 8. And then the second two terms, we're going to pull 7 out, and we're left with 3v minus 8. So we get 2v squared plus 7, and then times 3v minus 8. All right, let's see more problems. And these ones have multiple variables. Woo! All right, I know you guys. First, you stop in problem 9. 12, 3, 8, 7, and I don't have a variable or a number, and there's not a variable that's common for all of them. So we're going to go in and start in the first one. So 12 and 3, I can squared u and x squared v. So I can pull out x squared. And so I'm left with 4 in u plus b on that one. And my second set of and a y. So when I divide that out, factor that out, 4u plus b. Well, that's close enough. All right, those match. So 4u plus b, and then a 7x. Oops, sorry, jumped the gun on that one. Plus other than 3x squared plus 7y. All right. 4u plus b and 3x squared plus 7y. All right. Give the last one a try. Look for GCF first. If not, then break it into your two. Okay. All right, taking a look at this last one, the 40 and the 25, we can factor out a 5 and an a, and we're left with 8c squared plus 5k squared. And then in the second set of parentheses, 32 and 20, we can take out a 4 and a b. So we have for a solution 8c squared plus 5k squared. And then parentheses 5a plus 4b. All right, factor by grouping. We are going to carry this concept over into 4-3, but we have a quiz first. All right, thanks, ladies and gentlemen.